To a recording for chemistry, we're looking at metric units. For metric units, a definition we're looking at says that they're units of measure based on multiples of tens. That's what makes the metric system such a nice system, because everything's multiples of tens. Now, what kind of measurement are we looking at? We're looking at length, which is in meter. We're looking at volume, which is in liters. We're looking at mass, which is in grams. We're looking at temperature in Celsius, and we're not going to actually measure it, look at today, but we do have time, and time is recorded in seconds. All right, now let's look at our first one. Before we do that, I'm sorry, prefixes. Now there's a lot of prefixes in the metric system. For my class, we only have to have a few here, and those are kilo, deci, centa, milli, and nano. You can do this, stop if you need to. Kilo means 1,000 of. It's the only one that we work on that's greater than 10. Dec is a tenth of. Okay, make this a little smaller. Dec is a tenth of. Centa is a hundredth of. A millionth of, or 1 times 10 to the negative 9th. That's a scientific notation. We'll look at that value later when we do unit conversions. All right. Okay. First of all, meter. How do we identify a meter? Definition of a meter. Meter is the wavelength of krypton light. So we take krypton light, the length of that wave is exactly 1 meter in light. Now, unfortunately, makers of Superman were not scientists, because krypton light is actually purple, not green. How do we measure using gradient sticks? I'm not going to be happy, but we're going to watch this quick video. We're going to make a measure this time with a meter stick or ruler. When we start measuring, we never use the end. The reason we don't use the end because they're rounded. So we're going to start here at approximately 80. So that's going to be my 0. And you'll see this goes up past 92. So 80 minus 92, that would be 12. And when I look at this from 80, it looks like it's right on the 7th line. And we can make an approximation between the 7th and 8th line. So because it's right on it, we call that 0. So this would be 12.70, and meter sticks or rulers get measured to 2 decimal places. So my measure there would be 12.70 and 2 decimals. That's it. We're going to make a... No, we won't. All right. Next. We're going to look at liter. Oh, that one's a little bit off. Let's go back. Liter. All right. Now, a liter is equal to 1 cubic decimeter. Remember, we talked about a deci means a tenth of. So a box that exactly 1/10 of a meter, length, width, and height. All right. Now, the unit we use to measure that is a graduated cylinder. Graduated cylinder looks like this, and again, quick video. Okay, we're going to show how to make measurements with a graduated cylinder. So when you do that, you see the meniscus, that's the bottom of this little curve right there. You're going to go to the bottom of that, and graduated cylinders always get measured to 1 decimal. So what we're going to do is we're going to go down at eye level, and this is going to be, each one of those is 1, so it's a decimal. It's about half here. So this would be 21.5 milliliters. So that's how you measure it. Always with a graduated cylinder, it's 1 decimal. All right, very good. Now, next, we're looking at a gram, as we already saw. Okay, a gram. A gram is equal to 1 cubic centimeter of water. Now, if you were to go to Europe and say that the gram is a standard unit, they would laugh at you because it's way too small. In reality, a kilogram is actually standard because it's large enough to make a measurement with. We're going to use a triple beam balance to make that measure. So here is a triple beam balance, what it looks like. And again, the video. This time we're going to show the measures, how to make measures with a triple beam balance. The first thing that we want to do when using triple beam balance, and I'll show you over here, is zero it out. And the way that we do that is a little knob on the outside. Now, if you hold the edge here, you see this is a little low. So I'm gonna screw this out just slightly to bring it back up. So it balances right about there. Put an object on the balance. And we start with the heaviest mass, which is the 100. So that's at least 100 grams. 200 grams, 200 is too much, we go back. Always keep it inside the grooves. 10, 20, 20 is too much. Now we use a pen, and we use the slider with a pen. And it begins to move down. So it's right about there. So we're at 113 point. Now we count how many lines we have here. I'm past the second line. I'm almost the 8th line. So, I'm sorry, second line, almost the 3rd line. I would call that approximately 8. So my measurement here would be 113.28 grams, and triple balances always get measured to 2 decimal places. All right, good. All right, and last thing we're looking at here is thermometers. When we're looking at Celsius, the way that we identify it, Celsius boils at 100 and freezes at 0. There's also another measure we could use that's called Kelvin. To convert from Celsius to Kelvin, we simply add 273. So we go from Celsius to Kelvin, we add 273. To go from Kelvin to Celsius, subtract 273. Kelvin is an absolute scale. It does not, it has to do with vibrations. All right, now last video. All right, there we go. Last thing we're going to measure up here is with the thermometer. Now, a thermometer, again, when you push on these, we always push at the base. We never push at the back. And the reason is I've had a fellow student of mine in high school push it, it smacked, and went all the way back down his arm. It was not a pretty sight. All right, so again, we have many, many, many small lines here. These are all each one is at 1 decimal between each of these. There we go. So we're going to go to 1 decimal at this temperature right now. Oh, first thing, I'll make sure also there's no gaps in this. This is an alcohol thermometer. We don't have mercury. Mercury, very bad. So we have no gaps. If there is a span up here and you give it to me, it's not accurate, and so we'd have to redo some adjustments on that. Right now with this it's at 30, and it's right at the 35th line. So since it's exactly on the 35th line, we would say that would be 35.0 degrees Celsius. Again, then these go to 1 decimal, okay? All right, that's good. All right, so last thing we're going to look at is the definitions of precision and accuracy. Precision is defined as the closeness measure to previous measure. Accuracy is the closeness of measure to a correct value. If we can only have one, which would you prefer? I want you to think about it. We'll discuss that in class, and the way that we show that will be a little bored. Okay, that's it for class today with this. Take care, be good, bye.